Hello, today we will continue our discussion with generation and detection of SSB-SC and VSB-SC. The topics to be discussed today are the single sideband suppressed carrier modulation technique, mathematical expression for the SSB-SC signal, generation of SSB-SC, SSB-SC demodulation by squaring synchronizer, bandwidth of SSB-SC wave, power calculation of SSB-SC wave, advantage and disadvantage along with applications for the SSB-SC signals, vestigial side band modulation technique, necessary condition for the VSB modulation, bandwidth and advantages of VSB-SC, some disadvantages and applications of VSB-SC, as well as some problems and solutions. The single sideband suppressed carrier signal has been proposed after the invention of double sideband full carrier and double sideband suppressed carrier waveform. As shown on the right hand side, the spectrum of the modulated signal, which was started from the DSB-FC, has three components. That means lower sideband, upper sideband, and the position of the carrier. In case of DSB-SC, we have suppressed the position of the carrier. That means there is no unmodulated carrier signal, because that was one of the disadvantage of the DSB-FC, in which the carrier signal consumes the power which is not bearing any information. That is why two number of sidebands were transmitted. But afterwards it has been found that one of the sideband is sufficient for the transmission of the information, because both the sideband are carrying the same information. So therefore simultaneous transmission of the two sideband is nothing but a wastage of power. So that is why one of the sideband is sufficient for the transmission, so that there will be no such loss of the information. So in case of SSB-SC, we are dealing with the transmission of one of the sideband, that may be either upper sideband or lower sideband. The mathematical expression for SSB-SC is quite straightforward. That means earlier we have considered the expression for massive signal, which was AM cos 2 pi FMT, and the expression for the carrier signal, which is AC cos 2 pi FCT. Now if we use DSB-SC, we have seen there is a unmodulated carrier, upper sideband and lower sideband. Thereafter DSB-SC, which is having only one of the two number of sidebands, not the carrier. And here in SSB-SC, either upper sideband or lower sideband will be transmitted. So therefore filtering plays an important role for the generation of SSB-SC, because one of the sideband has to be collected properly and that will be transmitted. So for the generation of SSB-SC, we can explain the generation procedure from this spectral characteristics, in which the first spectrum at the top, it is showing the spectrum of the message signal, which is limited to the frequency W Hz. That means the message signal is taken band limited by some highest frequency component, which is W Hz. Therefore the DSB-SC could be produced which is having the bandwidth 2 times of W, and here upper sideband, lower sideband both are present. So after the generation of DSB-SC, if it is passed through a filter which can filter out one of the sideband, then SSB-SC could be generated. So using the blue spectrum, it is showing the upper sideband has been filtered out for transmission, and by the red spectrum it is showing that the lower sideband has been filtered out for the transmission. So for this center frequency, commercially 455 kHz and 10.7 MHz are available. But if we go for other frequencies, the expense will be more, because the utilization is less in other frequencies. Therefore in this method, DSB-SC signal is generated simply by using a simple product modulator or balanced modulator. This DSB-SC contains two number of sidebands. One of the sideband is filtered out using a bandpass filter, and this is shown here clearly. Now for the generation of SSB-SC signal, there are two methods of which the block diagrams are shown here. One is the phase shift method, another is the decay Weber method. So apart from the normal filtering process, these are the two methods which are popularly used for the SSB-SC generation, because SSB-SC is having almost all types of applications regarding the analog modulation technique. In case of phase shift method, the message signal is connected through two number of parallel lines. One is directly going to the DSB-SC modulator, another is coming to the DSB-SC modulator via a 90-degree phase shifter. Now 90-degree phase shifter is also termed as the Hilbert transformer, because Hilbert transformer introduces 90-degree phase shift to any incoming signal. So therefore, the 90-degree phase shifted message applied to the DSB-SC modulator, which is nothing but a product modulator, it is a simple multiplier which is also taking another input as the 90-degree phase shift of the carrier signal. So these two are made multiplied, and thereafter we are getting MHT sin omega ct. Similarly, at the top product modulator we are getting MT cos omega ct. Now if these two signals are added or subtracted, we can get the upper sidebands or lower sidebands. The decay Weaver method, which is invented after 1950 based on the scientist named decay Weaver, was important. That means it has a special characteristics that initially the DSB-SC signal generated, which was discussed in case of phase shift method, the similar process has been incorporated at the first stage where the lower carrier frequency was utilized, and afterwards the similar stage may be repeated for the generation of the same DSB-SC signal with a upper value of the carrier frequency, that means higher value of the carrier frequency. And such a continuous transformation of the carrier frequency to a higher level has a benefit for the design of the amplifier or filter, because filters and amplifiers are proportionally expensive with respect to frequency. More is the frequency, more will be the expense for the realization of the filters or amplifiers. In case of phase shift method, no such precautions taken, but in case of decay Weaver method, the attention paid for reducing the price or cost of realization for such amplifiers or filters. So that is why decay Weaver method is more beneficial compared to phase shift method in terms of the cost of realization. And final stage is similar to the phase shift method, because it is also using the adder or subtractor for the generation of lower sideband or upper sideband. So this is the SSB-SC demodulation technique, which is nothing but a square synchronizer. Squaring synchronizer utilizes a nonlinear device in the first stage, which is called squarer device, that will produce the square of the incoming signal. So here SSB-SC modulated signal applied to the squarer device, therefore the same signal is squared so that the carrier frequency becomes 2 times. So that is why bandpass filter in the successive stage is also centered at 2fc, so that the frequency related to 2fc, 2 times of the carrier frequency, will be passed through the bandpass filter, and that will be fed to the phase lock loop. The phase lock loop is having the loop filter and voltage control oscillator, which is connected to the carrier frequency tuned to the carrier frequency of the modulator, as well as it should have matching to the phase, but if it is not matched to the phase, 5 phase shift can be assumed. Now finally we can get the output which is proportional to the message signal at the output of the receiver. The bandwidth of SSB-SC wave is quite straightforward, because the SSB-SC modulated signal is utilizing half of the sideband of the DSB-SC, as we already have seen, either lower sideband or upper sideband. So therefore, as the DSB-SC is having the bandwidth 2 times of the maximum frequency of the message, therefore for SSB-SC the spectrum is half of that, so that is, it is the message frequency only. So therefore the main advantage of the SSB-SC waveform is here, that is the bandwidth of the SSB-SC is almost same as the message bandwidth. The power calculation for SSB-SC, as we already have seen, the mathematical expression of SSB-SC is containing containing only one of the sideband, upper sideband or lower sideband. So therefore, the corresponding power calculation can be easily found out if we take the magnitude, and that is and the corresponding RMS value is taken. So if we square the RMS value, we can get the normalized power. If we divide it by R, we can get a specific power across the load of resistance R. So in this way, we can calculate the power of SSB-SC. So here one thing is important, that we should look into the RMS value of the signal voltage so that the power may be calculated. But we have to be fixed in the thinking that the upper sideband or lower sideband for which this power calculation to be made are normally equal. Power calculation of SSB-SC wave is still continued. Here upper sideband and lower sideband power has been shown explicitly. Now the point has come, the advantage of SSB-SC signal. So bandwidth or spectrum space that is occupied is lesser than the amplitude modulated or DSB-SC waveform. The transmission of more number of signal is allowed because here the amount of bandwidth has been reduced. So if we accommodate the modulated signal over the frequency spectrum, there is a chance of multiple number of stations could be accommodated, which is larger compared to the DSB-SC, because DSB-SC is having the bandwidth 2 times that of the SSB-SC signal. The power can be saved easily. High power signal can be transmitted because here only one of the sideband is transmitted, which is saving almost 50% of the power which was transmitted for DSB-SC signal transmission. Less amount of noise is present. Yes, it is obvious. When the range of frequency in the modulated signal has been reduced, the amount of contamination of the signal by the noise has also been reduced. The signal fading is less likely to occur. There are some disadvantages. The generation and detection of SSB-SC wave is a complex process. The quality of the signal that get affected unless the SSB-SC transmitter and receiver have excellent frequency stability. And the receiver designing is also complex because here the coherent detector has to be utilized for SSB-SC signal, where the proper matching to the phase and frequency is an important. So for this, circuit is little bit complex compared to the earlier cases. Regarding the application of SSB-SC signal for power saving requirement and low bandwidth requirement, it could be utilized in land, air and maritime mobile communication system, point-to-point communication, radio communication, television, telemetry, radar, military communication such as amateur radio. In many applications, this SSB-SC signal could be utilized. Now let us come to the most realistic modulation technique, which is the Vestigial Side Band Suppressed Carrier modulation. Now this Vestigial Side Band Suppressed Carrier modulation is nothing but the substitute of SSB-SC signal. There are some limitations of SSB-SC signal generation which is overcome by the Vestigial Side Band Suppressed Carrier waveform. Now in case of VSB-SC, what happens? One of the sideband is completely transmitted, and there is a vestige or small part of the other sideband which is transmitted along with the sideband transmitted for VSB-SC. So therefore, it is similar to the SSB-SC, but a little bit compensation of the power is allowed because of the power, the frequency suppression due to the sharp cutoff of the filter. So if there is a sharp cutoff of filter, small vestige of the other sideband may compensate that much deficiency of the power which was happening for the SSB-SC signal. Now here VSB-SC signal has been clearly shown. So it is the necessary condition for DSB-SC demodulation. So to discuss this, let us have the VSB-SC modulator block diagram, which is taking the message as well as carrier signal to the product modulator. The product modulator produces the signal which is passed through a VSB filter. Now here we will determine the condition for the VSB filter. So VSB filter is having the transfer function HF assumed. Therefore, the spectrum of the VSB signal is given by m of omega minus omega c plus m of omega plus omega c multiplied by h omega. So when this VSB spectrum is passed through the demodulator, which is also incorporating one product modulator, the output of the product modulator might have a spectrum which is given by uh, uh, x of VSB omega minus omega c plus x of VSB omega plus omega c. Now, if you replace the x of VSB from the modulated spectrum, then eliminate the higher frequency component, that means 2 omega c. If you eliminate, then the final expression, that is the low pass filtered output of the demodulator, is half of m omega multiplied by h of omega plus omega c plus h of omega minus omega c. Now here the only condition, the only necessary condition for the VSB modulation technique to work satisfactorily is that h of omega plus omega c plus h of omega minus omega c must be equal to constant or unity. Otherwise, our output will not be proportional to the message spectrum. So, for this reason, h of omega plus omega c plus h of omega minus omega c, such a mathematical expression should be equal to constant for all the frequencies less than the message bandwidth, because message bandwidth is the highest frequency component present in the message. So we are interested to the frequency components for which this condition to satisfy should be less than the highest component of the message frequency. Now the bandwidth and advantages of VSB-SC are in this way we can tell that bandwidth of VSB-SC modulation is little bit higher compared to the SSB-SC, because here we have used the vestige of the other sideband or small part of the other sideband, so that if there is a sharp filtering, it will compensate the amount of power which is suppressed for some frequency components which are carrying important information. So that is why vestige of other frequency component is introduced, and that is why little bit higher spectral component, spectral range can be found for VSB-SC compared to SSB-SC. So this is one of the disadvantage of VSB-SC compared to SSB-SC, though SSB-SC is having more difficult situation. That is, if a sharp cutoff filter is utilized, then an important information which has no compensation technique utilized may be suppressed. But here a compensation is made by the vestige of the other sideband. So that is one of the great advantage over the small amount of disadvantages, little bit higher spectrum. So higher spectrum means little bit more money you have to pay to occupy the channel. Advantage of VSB-SC modulation is that it is highly efficient reduction in bandwidth when compared with the amplitude modulation or DSB-SC modulation technique. Filter design is very easy since high accuracy is not needed. The transmission of low frequency component is possible. So without any difficulty we can utilize this one. Processes are good with phase characteristics. There are some disadvantages of VSB-SC. There is following disadvantages are the bandwidth is more when compared to SSB-SC, a little bit more. Demodulation is complex. But applications, almost all the radio receivers and television receivers are utilizing this VSB demodulation technique because the realization of the circuit is less complex and less expensive. That is why it has a wide commercial application. There are some problems and solutions. So here the message signal is given, amplitude modulated with a carrier is given. So here you have to find out the modulation index, which is the ratio of the message magnitude to the carrier magnitude. To find out the carrier power, carrier signal is given 50, so 50 by root 2 is the RMS value. So if you take the square, then you can get the carrier power, and the total power required to transmit the AM signal is nothing but PC into 1 plus mu square by 2. So mu you know, carrier power you know, therefore you can find out the total power. So it has been continued to find out the total power, which is 1275 watt. Regarding the second problem, it is showing the amplitude modulated signal we have to find out the carrier power. We know the carrier magnitude, which is present 20. If we take its RMS value, then we can find out the corresponding carrier power. And total sideband power means except the carrier power, there is total power. We know PC into 1 plus mu square by 2. Mu is the modulation index, which is 0.8 here. From the expression, it is quite explicit. Therefore, if we subtract the carrier power from the total power, we can find out the sideband power of the FM, of the amplitude modulated signal. And the same has been carried out here. There are some MCQs. So MCQs are mathematical. If you go through the mathematical formula, which has already been discussed, all these problems could be easily carried out. So as a homework, you can continue to solve these problems. Thank you.